Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 286, and today is our lesson number 178. Page 286, the very last problem on the page, number 130. In problem number 130, they're simply asking us a volume of a certain rectangular solid without actually telling us anything at all about it. So let's see what they tell us in the two statements. In the first statement, they tell us that the two adjacent faces have areas of 15 and 24. The question is there enough information there for us to figure out, for us to ascertain the volume of this rectangular solid? The answer, unfortunately, is not, because simply knowing that the area, if they had told us the area of three faces, that would have been a different story. Simply telling us area of the two faces, here's thing to do here is to think of some weird scenario, some scenario that most people do not think of. For example, what if one side is only one? If one side is one, we could possibly be looking at a rectangular box that looks something like this. Let's say this is 1 and this is 24, so this face that you see there has the area of 24, and then this side is 1, and maybe this side is 15. From here to here is 1, therefore from here to here is also 1, and maybe this side is 15 again, and this is 1 by 15, this is 1 by 15, and this is 1 by 24. So we have two adjacent faces with the areas of 24 and 15. That's one possibility. Another possibility is something that looks a little bit normal, which is when you tell somebody to draw a rectangle with the area of 15, typically most people do not think of 1 by 15. They think of something simpler, something nicer, something more civilized, like 3 by 5. So maybe it looks like this. This is 3, maybe this is 5, so this area has an area of 15, and if this is 3, then this side is also 3, and maybe this is 8. So now the top part has the area of 24. This guy right here has the area of 24, and this guy has the area of 15. And of course those two faces are adjacent. Which one is it? In this case, the volume here is 1 by 24 by 15. In this case, the volume is 3 by 5 by 8. 3 times 5 is 15, so here we're talking about 15 times 8 as opposed to 15 times 24. This box has 3 times the amount of volume. The point here is not that it's 3 times, the point is we cannot tell which one is it. The first statement is not enough. First statement does not provide us enough information to tell for sure, definitively, as to what the volume of the box would be. And these are just a simpler scenario. We haven't even talked about the possibility of fractions. So there are infinite possibilities here. For example, we could have half and a 48. And same thing here, half and a 48 and half and a 30. And that would do the job. There are infinite possibilities. These are just the two of the simplest cases. We cannot tell. The first information is not enough. The first statement, that is not enough. A, D, B, C, E. Since the first statement by itself is not sufficient, the answer we know cannot be A or D. It would have to be either B, C, or E. Let's see what they tell us in the second statement. In the second statement they tell us that the two opposite faces have areas of 40. Let's see how they actually phrase it. Each of the two opposite faces of the solid has area of 40. But what does it tell us? Absolutely nothing actually as far as the volume is concerned. As far as the volume is concerned, what they have told us is that we have length times width times height here, and we are told that the area of the one face is 40, which means length times width is 40. Length times width must be 40, but in order for us to find the volume is going to be 40 times the height, and the volume of the box is going to vary with the height. The deeper the box, the more space you can put, more space it has inside it, the more stuff you can put in it. Unless we know the height, we cannot figure out the volume. All we know is that the two sides multiplied together give us 40, but that's not enough. What about the third side? The height is not given. Second statement by itself is also not enough. Let's move on. Let's put them together, see what happens. If we put them together, we know that two adjacent faces have areas of 15 and 24. 15 and 24, so maybe let's say length times width, and since they are adjacent, which means they have to share a side, so if it's length times width, maybe this is length times height. So that part we know. And then second part, they tell us that the two opposite faces rather. Some people refer to these as sides, but proper terminology is the face, because side is considered the edges. Two opposite faces have areas of 40. So we have length and width, length and height. Maybe the width and the height is 40. Well, not maybe, that's what it is. That's what it is here, the width and height is 40. Is that enough to figure out the volume? The answer is yes. Why is it yes? I'm going to show it two different ways. Once with the picture, we're going to draw a little picture and we're going to show it that way. That's more of a little bit of a babyish way. But the proper way, the algebraic way, is this way. We now know the length times width. It doesn't have to be a precise length times width. We just know that the product of two sides is 15, and one of those two products is shared here. One of those two sides is shared here. So either length is shared or width is shared. Doesn't really matter. And then once we have that, obviously we took care of the length here, so this has to be width times height, because the width has to be shared by somebody here. Do you understand? So length times width is 15. Length times width is 15. So this is what we know. We know that length times width times length times height times width times height has to equal, what does it has to equal? Has to equal length times length, which is length is squared, width times width is squared, and height, where is height? The height times the height has to be height squared, and that has to equal, so that's the square of the volume. So length is squared times width is squared times height squared, we know, equals 15 times 24 times 40. Let's continue this on the top here, so we have the room. And like I said, in a second we'll draw a picture and we'll see what it looks like in a picture. So that's it. In order to figure out the volume, we just take the square root of both sides. Take the square root of this side, take the square root of that side. So volume equals length times width times height, which is going to be the square root of 15. 15 can be written as, because 15 is not a perfect square, let's break it up into 3 times 5, that's your 15 right here. 24 can be written as 3 times 8. And 40 can be written as 8 times 5. 8 times 5. What do we find? Now I'm going to erase this line here so we can actually start matching it. We have two 3's. Square root of 3 times 3 is 3. we have two 5s. Square root of 5 times 5 is just 5. And we have two 8s. Square root of 8 times 8 is just 8. Voila, there is your volume. There is your volume. And that's what our final thing looks like. Where can we put it? Let's put it here. Our final thing now we know for a fact it looks like this: 3 by 5 by 8. 3 by 5 by 8. And this phase has the area of 3 times 8, which is 24, and this one has the area of 3 by 5, which is 15. So now we have two adjacent sides of 15 and 24, and the top one is 8 by 5, and the top face is 8 by 5, and so is the bottom one. So those are the two opposite faces with the area of 40, and that's what we're looking for. But the point here is that putting the two statements together definitely tells us which particular rectangle, which particular rectangular box we are dealing with, and that's what it is. And since two statements together do the job, answer is C. The first statement by itself did not get us anywhere. Second statement by itself was even more weak. Second statement by itself was even more open. But putting them together, there are enough constraints there that you can tell for sure that this is situation. One face by the other face, we know the area of the faces, and when we multiply the three faces, that comes out to be the square of the volume. And if we know the square of the volume, we can figure out the volume. I'll see you tomorrow, okay? Bye now.